Mark, inundated with emails this morning, pre-Australian Grand Prix, the build up to the race. Normally, we're kind of ready for what we're going to be looking at and tire pressures, compounds, things like that. But all of a sudden, in this new era, we have power and energy limits for this specific circuit. Presumably, this is going to come out for every race now. So it looks daunting, to say the least, for the fans, for TV commentators, for everyone really. But I'm just wondering if you can perhaps now talk us through, and I, looking at it from the perspective of a fan who just loves Formula One, will pick your brains as we're going along as to what actually is going on here and how significant all of this is.
The first one is the power and energy limits that have been defined by the FIA. What's interesting there is that, if you recall, normally the cars are allowed to recover up to 9 megajoules of energy on a lap, but the FIA reserved the right to adjust this level. And for Melbourne, what they've done is they've set the normal lap recovery at 8 megajoules, so 1 megajoule less than the absolute maximum. And in the overtake mode, only 8.5 megajoules. So that's half a megajoule down on the maximum that's allowed. In qualifying, and this is something that I wasn't expecting, they've actually reduced that to 7 megajoules. So that's quite a bit below. I'm guessing that the reason they're doing this is basically because on this track, the cars are going to struggle to recover the full amount. And presumably there might be some variation in capability between different PUs. And so by limiting it, they're kind of equalizing the field to some extent. Although I suspect that even these lower levels than the absolute maximums are still going to be quite difficult to achieve. So if one PU has got an advantage, I think that will still show up. At this point, I haven't put enough thought into why for qualifying they might have reduced the limit. But I'm guessing that because the cars leave the garage probably with a full battery, it actually means that the cars have less need to do recovery on a qualifying lap. And so effectively the laps will just be a bit quicker because they won't need to recover as much. But where it will be interesting is if you want to do a fast, slow, fast, obviously you have to do some recovery on the slow lap. But in some ways that doesn't make a big difference because, as we've talked about before, this on this track, the 7 megajoules for qualifying, the battery is only giving a 4 megajoule swing. So they're still going to have to do 3 megajoules of recovery to deploy that extra amount around the lap. Anyway, it's just interesting how they've broken this down into a number of different areas or levels. And it would just, as hopefully as the season goes on, we get to understand more about why they're playing around with these numbers.
And do you imagine there's going to be differences for every circuit for the time being?
Yes. Oh, yes, there will be, definitely, because there are some circuits where it's going to be a lot easier to do the recovery. And I imagine that those will have the maximum of 8.5 for normal laps and 9 for the overtake mode. But the majority of circuits, I suspect, will be limited to a lower level. And I suspect there will be circuits where it's probably even lower than this circuit.
So just condensing that from a fan's point of view, basically everybody's in the same boat. That's the first point. So, and it may even out some differences between one power unit and another. Possibly. Yeah. And if the Mercedes and Red Bull powertrain engines for the next 5 races, or 7 if the Middle East are not postponed or cancelled, if they do have an advantage with their compression ratio thing, will this reduction in fact nullify some of that advantage, or will it make no difference to the internal combustion engine side of it?
If it makes a difference, so the benefit of that combustion is really just to make the car obviously a bit more power, so the car will go a bit faster. So going into a corner, if you're traveling at a slightly higher speed, you'll be able to recover a little bit more energy. But I don't think it's going to be big numbers. So yes, it could make a small difference.
But if I can just interject here, but in reality, they've got to recover less energy now, and so their advantage is slightly smaller because everything's reduced.
Yes, effectively. But as I say, I actually wonder if they'll be able to recover this, even this limited amount. If the cars will be able to recover this limited amount
Oh,
anyway.
wow.
In which case, I suspect that it probably won't have a big effect on any advantage that a car might have.
So what you're saying is you think it might be difficult for anyone to recover 8 or 8.5
Yeah, I think so. Yeah.
because of the nature of Melbourne.
Particularly, yeah, because it's a sort of medium braking circuit. So it's sort of bang in the middle. But I think in order to be recovering the 8 to 8.5 megajoules that you can on, well, the 8.5 that is the maximum according to the regulations, I think that's going to be circuits with lots of braking are the only ones that are going to, where they're going to be able to do that. From high speeds. So I do suspect that certainly initially, I'm sure as the companies develop their power units, they will get better at it. But I think to start with, there's going to be quite a lot of difficulty just maintaining the levels or achieving the levels that are allowed.
And I'm assuming there will be telemetry and there will be access for the fans, therefore, to be able to see how much has been recovered at the beginning of the next lap. I'm assuming that's the case, but bearing in mind that's every lap of every car, that's a massive amount of numbers and information out there. And it also opens the door to a driver saying quite correctly, oh yeah, I'm half a second off the pace, but don't forget I did that with only 7 instead of 7.3 that he had. And it'll bring in all these other variables, won't it? That, you know, who's quickest in the under 7 class sort of thing, you know? There'll be all that stuff.
It's possible that particularly if drivers end up having to do multiple laps, say in qualifying, because the tyres are on the hard side and they need to do that to warm them up, if they're struggling to recover the energy, then they're going to get slower because of that, even if the tyres are getting better. So, and in the race, I think this is going to be a bigger issue because obviously they're doing multiple consecutive laps from start to finish. And if someone's struggling to recover the energy, you're going to see their pace dropping quite quickly, potentially. Yeah. It's going to be very interesting to see. And I suppose that is going to be the question is it going to be obvious to us as the spectators that this is what is occurring?
Well, yeah. And being obvious is one thing. Actually understanding it and applying it to what is going on is something else again. The next box, maximum power reduction rate.
Yes, so not only are they limited on the amount of energy that can be recovered and deployed, but in the zone, as we know, we've talked about previously, with speed, there is a relationship to the amount of electrical power that the car can be powered by, and that declines. And you can see in the graph we have for Melbourne, and this is the standard for all events, from 290 kph upwards, the amount of electrical power reduces. And what they're saying is that not only does it reduce with speed, but you have to have a rate limit on that reduction as well. So what they don't want the car to do is to slow down dramatically, very suddenly. They want the car to reduce speed progressively, or the power to reduce progressively, so that it doesn't disrupt the car behind, presumably. And remember, this is where the difference in overtake mode and normal mode comes in, is that in overtake mode, you're going to have this, you're allowed to deploy this electrical power for up to higher speeds. And that's what's going to give the car behind the ability to overtake the car in front.
Okay, and that you think those numbers there are basically locked in and they're going to be the same in every race? Or is that dependent on how long the straights are, I suppose?
There's a power limited distance shown, which is going to be, I presume, circuit dependent, because that's the actual measured. That's what they're simulating as the time, the distance that the driver will be at full throttle on the circuit. I don't know how. Well, basically, I think it's difficult to interpret what that actually means without being party to the discussions, and whether that applies a limitation. I'm not sure about that, to be honest. They can't be. They can't be saying. They certainly can't be saying you're only allowed to deploy maximum power for these number of meters. That wouldn't make any sense. So that number I don't understand. I'll be honest. The 50 kilowatts per second rate limit, I imagine, won't change, but could do if they find that the cars are slowing down too dramatically. They could decide to make that a lower number, so that the slowing down of the car is less, which would just mean that they have a bit more power for longer, for instance.
And just to recap, the reason we have this stuff at speed is under the heading of to try and promote overtaking.
Well, it's two things. Firstly, basically, the cars haven't got enough power, battery power, to be at full power all the time. But there just isn't enough power to do that. But what they're proposing is that by reducing electrical power with speed, you are generating an offset to a car that is allowed to run the power for longer. So a faster car should theoretically be able to generate more power, more battery storage, because it's not having to go at full pace. So the driver is able to recover more energy than the slower car ahead of him. And then he's given the opportunity to deploy that extra energy to overtake that car ahead.
And when you say faster car, you mean faster through the air in a straight line terminal velocity? Is that what you mean?
I meant lap time.
Oh, okay.
So a car that is faster by lap time has come up to another car that is slower by lap time. So he's being held up. That means that he should be able to recover more energy than the car ahead of him, because he doesn't have to go flat out. He can use more straight line recovery. He can use more partial throttle recovery. He can build up his battery, and then he can use that extra energy with the overtake mode to go past that car on the straight.
But what if the car in front is slower on lap time, but substantially quicker in a straight line?
Well, in that case, you're kind of screwed. But then that's no different to when we had cars with low downforce ahead and cars with high downforce trying to use DRS behind.
Except that it kind of worked in that situation, because that's the one thing DRS did do. It enabled Fernando Alonso to pass Vitaly Petrov.
Yeah. There is a very big power differential from these two modes, the normal mode and the overtake mode.
Right.
So I suspect that it will be enough in most situations for the car behind to overtake. And also, obviously, the effect of the new rules means that the differentiation in aero level between circuits is probably going to change, in as much as because you can back off the wings on the straights, there's going to be less need to have a very low downforce rear wing. So I'd imagine that the difference in downforce levels between wings across the season and between cars is probably going to reduce. So I think there'll be less chance of a car having a low downforce spec on it that means it's much faster than a car with a higher downforce spec. I think that differentiation will reduce significantly.
All right, well, let's move on to the overtake numbers there now. What do you make of that?
So the detection gap is now something that's defined. So basically the gap between the leading car and the car that's trying to overtake it is now something that isn't necessarily going to be 1 second at every track. The FIA reserve the right to adjust that. It is 1 second for Melbourne, as they've said, and it probably will be for most races, I would imagine. And then all they've given is the position for the detection point and the activation point. So the detection point, which is on the map, is just after turn 13, which is the penultimate corner on the circuit. That the driver will get a signal to say you're close enough to the car ahead. On the following lap, you will be able to recover more energy. So the first lap, he will recover more energy. And then on the next lap, there's an overtake activation line, which is just before turn 14.
But just if I can stop you, when you say he can recover more energy, remind me on that lap, how much energy he can recover.
The ability to recover the extra half a joule of energy.
Yeah.
because he's in overtake mode.
Yep.
And then on the subsequent lap, once he crosses the activation line, which is just before turn 14, then he will be able to deploy that extra power down the straight to turn 1.
What if he's already passed that car in the previous lap? Does he still have that?
I imagine he will have that, yeah. He will still be able to do that. Because I think the detection is only going to be a one-off thing. And that was true with DRS as well.
Yeah, of course it was. Yeah, it's just that there's a lot more involved now, isn't it? If it's involving... And then we got the exceptions.
Now, I think this is very interesting. So, as we've mentioned before, the cars can recover energy when the driver's accelerating at part throttle.
Yeah.
And under normal circumstances, the maximum energy recovery rate is 150 kilowatts. But what they're saying here is that in basically turn 11 to turn 13, you are actually going to be allowed to recover up to 350 megawatts from part throttle. And this is clearly because they know that it's going to be difficult to recover the full amount of energy. So in this section of the track, they're allowing a much greater rate of recovery than is normally the case.
Again, can I stop you there, Mark? You use the phrase part throttle.
Yes.
What does that mean exactly? Does that mean anything other than full throttle? It can be 99% throttle?
I believe so.
Oh, and what if you use 100% throttle?
If you get to 100% throttle, you're not recovering any more energy. So it basically, in the power limited, so where you're grip limited, in the grip limited section, the driver will go to say 50, 60% throttle. He will get at the wheels the amount of torque that he's requested, but the engine throttles, the ICE engine throttles will be opening more to deliver more power to the drivetrain to power the MGUK to generate electricity.
So in that section, if a driver is using more part throttle than another driver, is that going to give him more power sooner? And what can he do with that extra power, I guess is what I'm saying. And is there an advantage for a driver being able to do that?
Yes, so he can deploy that extra energy that he's recovered around the rest of the lap, basically. Because the electrical energy, the main advantage comes in initial acceleration. So it's the range when the driver gets to full throttle, just gets to full throttle, that's the point where you need the most amount of power.
Yeah.
And that's where the advantage comes from. So it is actually more efficient when you're grip limited. If you can recover energy to convert to electrical, you have an advantage, because basically that's just making the car more powerful when you need it, which is when you are becoming power limited rather than grip limited.
So are we thinking that between turns 11 and 13, what you'd want to have at the end of FP1, FP2, throughout all the sessions, actually, maybe not the race because there's so many other variables, but all the sessions, you'd want to have the average that all the drivers have managed to achieve in terms of how much throttle opening they've got, to see who's done the best job of having the most throttle and therefore generated the most speed without sacrificing lap time. Is that right?
That's the key to it, though, isn't it? It's the without sacrificing lap time.
Yeah. Obviously, if you take all their quickest laps and what throttle they had at that point,
yeah,
isn't that going to be quite a significant pointer to how they did the lap?
You're only going to be seeing the throttle if you just measure throttle pedal position.
Yeah.
That's not going to change. What's changing is the throttle actuation on the engine itself, because the engine will be providing more power to its drivetrain.
Oh.
It's kind of recirculating.
So
driver, this will be completely invisible, or it should be.
Well, it sounds like for the fan it will be as well then.
Yes. Yeah, I don't think this is going to be something that is really noticeable.
Not noticeable, but it's unbelievably significant.
Yes.
Because some drivers will have this ability, won't they, to do that, I imagine. Or does it depend on? I mean, if you got Jacques Villeneuve with an on-off throttle switch with his, unbelievably stiff throttle springs, and another driver, Ayrton Senna, with incredibly soft throttle springs, how does that affect it?
Um, it's going to be the area above the curve of the throttle pedal input. So yeah, I'm struggling to visualize it myself. But you obviously need to maximize your grip. So you want as much power going to the wheels as is possible to accelerate the car as quickly as possible. But what you want above that is the recovery to the MGUK to be, or by the MGUK to be as high as possible. So I must admit I'm struggling to get back.
And there's something else here, Mark. You're talking about things above the graph and all these actuation things. I mean, what if one of those goes wrong? One of those elements in one engine goes wrong anyway. I mean, there's so many parts to this now. It seems to me, some of it's software, some of it's sensors, some of it this, some of it that. They can't all run perfectly in race one.
This is something that was happening previously. This methodology is not new. What's new about it is the fact that the MGUK is much more powerful than it used to be, and so limits are being placed on recovery, which weren't previously the case. As far as I'm aware, I might be wrong on that, but because much less power was being recovered before, it was it was part of the process, and it didn't really influence things. Whereas now, they seem to be more. They seem to be concerned not to allow too much recovery at part throttle, and that's something that I'm not sure why that is. Maybe they're thinking that people could use it as a kind of traction control or something. I'm not 100% sure, or partly maybe it's just because they're a bit embarrassed about the fact that fuel, petroleum, is being used to generate electrical power on the car, and they want to try to minimise that. I'm not sure, to be quite honest, but it's interesting that they are now placing very public limits on what is possible, so making it a talking point when previously it just wasn't at all.
And do you think that the FIA have come up with these numbers and limits after detailed discussions with all the teams and studying all their telemetry from Bahrain, or do you think they're doing it behind closed doors and the teams are all shocked or surprised or whatever, or pleased?
No, I don't think the teams will be shocked at all. I think this has been part of the discussion process that's been going on for years, to be honest. There is a technical group within the FIA that has access to simulation modelling, and this will have been discussed with the power unit manufacturers, and they will all be aware of what's going on completely. And the PU manufacturers will have been involved in even suggesting limits, I would imagine, up to a point. So yeah, I'm sure this is all completely understood, and the teams have had a long time, or the PU manufacturers have had a long time to work around it.
Well, no excuses then. Good. I mean, it seems to me that we can look at this from the point of view of, well, we'll just see what happens on track and who's in front and who overtakes and who wins the race, and that's it. Or we can try and understand how all that happened. And if the normal culprits win the race and it's the normal looking race, that's fine. But if I don't know, if a Pierre Gasly or a Liam Lawson wins the race, driving beautifully seemingly throughout, we'll need to know what is going on in that car and that power unit that's enabled him to do that. And it could be as a wild card as that. I think it seems like.
I think that's what we need to find out, isn't it? I think it certainly will be of interest if a car that was going quickly starts to go less quickly, or a car that qualified very quickly in the race performs badly, or vice versa. I think it is potentially going to be down to these sorts of things that could have a bigger influence than before. We're used to talking about, this car's got more downforce than that car, and that can explain this and that, or this driver's got more tyre degradation, or this driver's front tyres have grained. Those things are things that we're used to talking about. But I think we are now entering the realm where these other issues to do with power, recovery, and deployment are going to have an influence on the results. And I think it's going to be a challenge for F1 to make that digestible and understandable for everybody, frankly. It is going to be a challenge. And what worries me a little bit is obviously in some countries you can pay for your subscription to the F1 app and it will give you access to more information, which is fine. In the UK, you can't do that because of Sky Television's contract with F1. And what just concerns me is that if this becomes significantly influential and you don't have the app, or you're in the UK and the presentation is on Sky isn't up to standard, which it'll be very good, I don't know. But it just worries me that we might struggle a little bit with this to start with. On the other hand, it might be that this turns out to not be much of an issue at all, and the races just go ahead and we don't even notice these influences. So it's all part of the interest in these first few races.
Right, moving swiftly on to tyres. 18-inch wheels, but different tyres this year, and we're seeing the significance of that already going into Melbourne, right?
Yeah, so one thing I actually, looking back, this was also true for Bahrain, but basically the tyre pressures this year are much higher than they were last year, particularly the rear tyres. And that is surprising to me because the cars have less downforce than they had previously. And in the past, the reasons why pressures have been raised is because the loads have gone up. And to basically prolong the life of the tyres, they've had to do that to make them structurally sound. So I'm surprised that they've had to raise the pressures given that the cars actually have less load than previously. Obviously, they have made the tyres smaller, particularly they're narrower. The contact patches are already reduced by that size reduction, and going up on pressure reduces the contact patch size by an amount further. So for this race, the pressures are 1.5 psi higher at the front and 2.5 psi higher at the rear than last year. It's an interesting. Basically, it's done to protect the tyres, make sure the tyres survive. But it's just surprising that they've had to do that. And the drivers won't like it because it will make the car, the rear of the car, more difficult to manage fundamentally. And the teams, as they will have found in Bahrain from the same problem, will have to work around that with their setups.
Where it was a fairly friendly track surface and reasonably friendly weather conditions. Melbourne, a completely different story in every dimension, whether it be ambient, whether it be temperatures, track temperatures, whether it be the track itself. We know there's a pronounced crown at some points of the road there, and it's a street circuit, and it'll be incredibly green on Friday. With all the other stuff going on, Friday's going to be a hectic day.
It always is, and it's going to be even more hectic because there are so many changes compared to the previous year. When the cars were similar from one year to another, you had your sort of knowns and your unknowns, and you could focus on the things that were going to be problematical. This year, they're going into it with many more unknowns than normal. So it is going to be more of a struggle. And as you say, the weather does tend to be a bit more unpredictable in Melbourne. So if we do have, for instance, rain or a particularly windy session or something, it's going to make life even more difficult for the teams. On the positive side, Melbourne is less of a rear limited track than Bahrain. So although the pressure at the rear has gone up, it will have a bit less of an effect on Melbourne than it would do, than it did do in Bahrain. On the other hand, the fact that the front tyre pressure has gone up means that the front limitation just gets a little bit worse, and the tyre is going to be more prone to graining potentially and degradation all round.
So how you balance the tyre warming and then the out lap, the preparation lap, going to be really critical going into qualifying.
Yeah, I mean, this won't affect tyre degradation in qualifying is
Well, balance. I'm just thinking of balance in qualifying more than anything else.
Balance, it's going to be a challenge as always. Yeah,
Mm.
the rear pressure is higher than the increase in the rear is higher than the increase in the front. So it has swung it more to an oversteery balance from that point of view. The teams can they can change the vertical stiffness and the roll stiffness to maintain those values in the levels they want. But what they can't do is change the fact that they've lost grip. And they've lost more rear grip than front grip. So there is going to be a certain amount of rebalancing required. But Melbourne is always a pretty tricky track, I would say, anyway, because it is unusual in the amount of front loading compared to the rear. It is a challenging track to set the cars up. And if a car that has a strong front end without being overly sensitive at the rear, or a driver who can handle a car that is somewhat loose at the rear, they normally have an advantage on this circuit.
Compounds are the softest in the range, no surprise there. It'd be interesting to get on one of those track walks today, to see actually what they're talking about here, because basically all bets are off in terms of how you look at this race at the moment. Complete, almost clean sheet of paper, isn't it? I mean, where are we at with track walks now, anyway?
Track walks. I mean, obviously, the original point of a track was to go out and have a look at the track, see what issues there were with curbs, with runoff areas, etc. My experience was that over time they became more of an opportunity to do an engineering briefing, and the problem with that is that you ended up not looking at the track at all. You're just walking around the track talking about all the other things, which wasn't terribly helpful. And it's actually quite difficult to show drivers graphs and things while you're walking. It's much easier to do it when you're sat in an office. So some drivers, and I think the more sensible ones, will get on a bike, possibly with their trainers, and go out and cycle around the track separately to any track walk that they are required to do. The problem is their time. They've got a lot of media activity on a Thursday in particular, and I think one of the reasons why some teams do track walks is just to get away from the media side of things. But then even that doesn't work, because you end up getting requests to do photographs on your track walk and all sorts of things like that. So yeah, it's an interesting thing. But the fact is, most of the drivers I will work with later in my career, they didn't want to do track walks anyway. Kimi certainly didn't like doing track walks. Mika wasn't a huge fan of them in his later days. Kevin never did them. As long as they went out and had a look at the track.
Yeah. And most of them probably did at some point. Anyway.
I mean, the classic one I can remember is obviously Kimi and the runoff in Brazil, when he went off at the corner before coming up the hill.
Oh, yeah.
And he drove through the gates thinking that he could drive round the back of the barrier and back onto the circuit further up. And I think between his track walk and the sessions, they closed the gate. So he had to turn round and come back through the gates where he'd gone off and then back up the hill.
Not good. Not good. Those little incidents actually what make Formula One what it is in many ways. And let's hope we have plenty of little incidents like that actually take us back to ground zero when we're watching the Australian Grand Prix. Because if it comes down to all that other stuff, I pity the poor fan looking at the big screen, trying to work out what's going on. But anyway, the Aussies are as good as any when it comes to understanding sport and getting on with it and making it happen. So look forward to it. Mark, thanks so much for your time. Brilliant. And we'll pick your brains a little bit more as we go into the Australian Grand Prix weekend, if that's all right, because we're definitely going to need lots of help in understanding what's going on.
Yep, sure. Absolutely, Peter. Thanks very much.